Quantum computers can tap into parallel realities. This is a quantum computer. What you're looking at is the future of computing itself. Its function is drastically different than that of classical computers, which we know of today. Now, what makes it so different is that classical computers process everything in only two states, 0 or 1. And this is exactly where quantum computers differ from classical computers. Unlike the classical computers that use bits, zeros and ones, these quantum computers use qubits, which are a superposition of the classical bits. So if regular bits are 0 or 1, not both at the same time, a superposition of those regular bits would be 0 and 1 simultaneously. So what makes this interesting is that regular bits only have two possible positions, 0 or 1. But when processing with qubits, there is an infinite number of positions that lie within the spectrum between 0 and 1. Now, how a machine can process infinite amounts of data with a finite amount of time leads to speculate. That is only possible by accessing data from parallel realities. To help explain this further, here's a clip from the author of Quantum Theory Cannot Hurt You, A Guide to the Universe.
I mean, your computer can only do, it can store a number of a particular size because it's got the memory space. Where is the quantum computer doing the calculations if it's using more physical resources than exist in our universe? And David Deutsch, who's a physicist at the University of Oxford, says that what the quantum computer does is exploits parallel realities. It exploits copies of itself in parallel universes. So when you set a quantum computer a problem, it splits into multiple copies of itself in parallel realities. They all work on threads of the calculation, and they come back together again with the answer. So he says the quantum computer is something entirely new under the sun. It's the first thing we've ever invented that exploits parallel universes.